All right, so we're going to go ahead and graph both of these. I'm going to graph one here as a factored form. So the reason we call this factored form is because we see two binomials that if we multiply those together, we'll end up getting a standard form equation that we can also graph. So hopefully this helps anybody who is working on factored form graphing and standard form graphing. So here are the steps right over here. So the first thing we need to find and plot are the roots. Now I'm going to write a couple other words here. These could also be considered x-intercepts. That's another term that we use for roots, or zeros, or solutions. Okay, so basically it's just where the graph, the parabola, is going to be touching the x-axis. Now I'm going to look and see, is this graph going to be an upward facing or downward facing graph? The reason I know it's going to be an upward facing graph is because there's not a negative sign in front, and that means that we would be finding a vertex which would be a minimum, because the very bottom point there would be considered our minimum. So let's start by finding the roots, and to do that we would just set this binomial equal to 0 and this binomial equal to 0. And we're just finding the x value that will make this statement true. So to do that, I could add 3 to both sides of this. If I add 3 here and here, I would find out that one of my roots is x equals 3, and I'm going to write that as an ordered pair. That ordered pair would be 3, 0, and that's going to be plotted right here. If I set this one equal to 0 and subtract 1 from both sides, then that means that x is going to be equal to -1, and the ordered pair for that would be -1, 0. So I have this and this. These are my x-intercepts. Okay, and then to find the axis of symmetry, which divides my parabola right down the middle, gives me a line of reflection basically, is I'm going to average the roots, or average the x-intercepts. So my one x-intercept was 3, the other one was -1, so I'm just going to add those together, and I could add it 3 plus -1, or there's 3 minus 1, it's still going to result in the same thing. Divide that by 2 because there's two numbers that we're averaging. So 3 minus 1 is 2, and divide by 2, so it looks like my my axis of symmetry is going to be when x is equal to 1. And so that means I'm going to draw this line of symmetry right down x equals +1. To find my vertex, I need to plug the axis of symmetry into the function. So here's what I'm going to do. I'm going to replace the x with +1. So the result of 1 minus 3 is -2. The result of 1 plus 1 is +2. So this ends up being -2 times +2, or y is equal to -4. But this y value is part of the vertex, so it has to be part of the ordered pair. Remember, the first part of the ordered pair is the axis of symmetry. The second part of the ordered pair is the y value, which gives me my vertex right down here. So this is the minimum. It's our vertex. And the ordered pair for that is the axis of symmetry is the x value. And we just discovered that y is -4 for that vertex. Okay, so we could make a parabola out of these 3 points, but in order to make a smoother curve, we can find another point, and one of those points would be the y-intercept. We can see that it's going to actually connect with the y-axis here. So let's set, this is when x is equal to 0, right? Because if we're thinking about where where our graph is going to cross, that means that x is 0 to find the point on the y-axis where it's going to cross. So I'm going to plug in the x equals 0 into my equation. So I'm just going to replace the x with a 0. So y equals -3 times +1. Remember, this is a multiplication problem. So y is going to equal -3. And that's just the place where it crosses the y-axis. That's not the ordered pair. So the ordered pair would look like, 0, because x was 0 and -3. So that's going to be right here. Now that's 4 points for my curve. But if I reflect this point over this axis of symmetry, this point is just 1 unit away from the axis of symmetry. So I'll plot another point on the other side. That's my reflected point. So this would be called my y-intercept. And I could probably label this as an x-intercept. That's one of them. This is the other one. Remember, another word for x-intercept is root, or zero, or solution. And now I will have the opportunity to smoothly graph these points, or graph my curve by connecting these points. Always put arrows on the ends of your curve because of course it's going to continue infinitely in that direction. So hopefully that helped you with your graphing factored form quadratics. Now we are being asked on this sheet to convert that function to standard form. So I'm just going to write my two binomials, one across the top, one across the bottom, and then multiply x times x would give me x squared, x times -3 would give me -3x, 1 times x gives me x, and 1 times -3 gives me -3. And I see that these terms are alike, so I'm going to be able to combine those two. Whoops, I think I have that wrong. That's actually going to be -2, isn't it? Okay, I can fix that. Okay. Now, we do have some different steps, okay? So we're going to use these steps shown over here to graph in standard form. And the first step is to identify the a value, the b value, and the c value. And these terms, a is always in front of the x squared term, b is always in front of the x term, and c is always the constant, which means it doesn't have a variable. And the c value is also going to be our y-intercept. Okay, and that's true anytime we have this form of the equation. So when we see our c value, we'll be able to actually just plot that right on our x-axis. Sorry, y-axis. Okay, so our a value is 1, and our b value is -2, and our c value is -3. And then, in order to find the axis of symmetry, see in this particular form, roots may or may not exist, you know, but we're not focusing on finding the roots, okay? We're focusing on these steps right here, which are different than the ones we had in the previous graphing problem. Okay, so we're going to just focus on these steps right here. The axis of symmetry, we need to use the little formula that I gave you in class, which was opposite of the b value divided by 2 times a. Okay, so the b value is -2. What is the opposite of -2 is +2. And then 2 times our a value, which in this case is 1. Okay, so this negative sign sometimes throws students off. It's always the opposite sign of whatever b is. In this case, it's going to be a +2 because the b value is -2. So 2 over 2 is 1. Now we already realized that our axis of symmetry was going to be 1 because in the previous problem at the top of this page, the axis of symmetry was 1. So these graphs are going to look the exact same, we're just going about it a different way. How do we find our vertex? We still plug in the axis of symmetry, so we're plugging it into the equation that looks like this time. So we're taking 1 and we're going to square it because that's what it says to do. We're going to put our 1 in place of this x and then subtract 3. So order of operations says we have to do things in a certain order. 1 squared is 1. -2 times 1 is -2, and -3 is the c value. So let's just go left to right here. 1 minus 2 is -1, minus 3 is -4, which we already knew because our vertex in the previous problem was 1, -4 also. This is just part of our vertex ordered pair. Okay, so our axis of symmetry value is the x value of the vertex, and the y value that we get when we plug in the axis of symmetry is that minimum down here. Okay, so our vertex is at 1, -4, and that's all we have so far is just that one point. So now we have to find our y-intercept. This is an easy one. It is always the c value. So our c value is -3. So our y-intercept is going to be 0, -3. Our x value is 0, and our y value here is -3. And we knew that already because we had this in the previous problem. So you hear me say that a lot. This equation is the exact same as the one that we did above. It's just converted into the standard form. So to get another point, I could reflect this point over here. Okay, so here's our y-intercept. Now I'm going to go ahead and complete the table, and this one doesn't have 5 or place for 5 of them. I'm going to go ahead and add another one in. We know our vertex is 1, -4. I always like to have 5 points for my parabola because it makes me make a nicer, smoother curve. The y-intercept is going to be 0, -3. We had this point, which we reflected, which is going to be 2, -3. And now, in order to get a couple more points, I'm going to find any x values that are close to the axis of symmetry. So one of the points that is close would be -1. Another point that would be close would be +3. So I'm going to go with +3 just because using negative numbers isn't my favorite thing to do. Most students say that to me anyways. So I'm going to go ahead and plug 3 in. So when I plug 3 in, I'm going to square it because that's what it says to do here. -2 times 3 minus 3. Okay, let's do this in order, of course. 3 squared is 9. -2 times 3 is -6. And minus 3. So 9 minus 6 minus 3 is just 0. Okay, we could have known that from the previous problem because one of our roots, of course, was 3. And now, because we know how far away it is from the axis of symmetry, I can plot that on the other side of the axis of symmetry, the same distance. So here we are right here. And that was -1, 0. So you don't have to show me both of those because this obviously was reflected, right? And we already knew that this one was also reflected. So you do have to find at least 3 points, but then you can use the axis of symmetry as a reflection or a line of symmetry to reflect points over that one. Then those are kind of like freebies. Okay, connect your curve nice and smoothly like that and draw arrows at the end so that we can indicate that that is going to continue on infinitely. All right, I hope this video has been helpful to you.